Hey guys, so today we're looking at algebraic fractions, and I really can't emphasize enough how important it is that you understand what's going on here, because it's going to come up again and again in this course, and if you can't manipulate algebraic fractions correctly, then you're going to keep making mistakes and losing valuable marks. So we start off with a really simple example. The final example is going to be quite complicated, but it's the same advice I give you in the other stuff. Take things one step at a time. You can do each step. You get intimidated when we put them all together, but if you break it down, you can handle this. Okay? So the simplest example you're probably going to see with algebraic fractions is like this first one. 3y minus 9 all over 3. Well, we have a common factor there of 3, which I can then cancel out. Now you're welcome to go straight to the answer of y minus 3. This is just to show you the process that we've... Okay, so the next example, 4x squared minus 9 all over 2x squared plus 14x plus 24. What you're going to need to do here is factorise, obviously. If we're trying to cancel out a common factor, then we need to know what the factors of these algebraic expressions are. So x squared minus 9 factorises very easily into x plus 3x minus 3. 2x squared plus 14x plus 24 has the common factor of 2, so we need to take that out first. And then what we're left with is x squared plus 7x plus 12. Now, I use the cross method. So we have x and factors of 12. 6 and 2, 3 and 4, 12 and 1, and we're trying to come up with 7x. So obviously we're going to get that from 3 and 4. So then when you're looking for the common factors, well, I can take out a common factor of 2, and I can take out the common factor of x plus 3. So this is going to simplify to 2 outside of x minus 3 all over x plus 4. So looking at the next one, if we are asked to simplify and we've got two algebraic fractions and we need to combine them, I am hoping and praying that at this point in time you are not going to tell me that the denominator of my new fraction is going to be 7. Okay? We need to come up with the lowest common multiple, and generally the simplest way to do that is to cross multiply 4 times x plus 7 and 3 times 2x minus 1. So we're going to have a common denominator of 12, and we're going to end up with 4 outside of x plus 7 plus 3 outside of 2x minus 1. Now it's important that these two factors here stay in the same order. Not so much when we're adding, of course, it doesn't matter which order we add, but when you're subtracting, that's going to have an impact. So keep them in the order that they're in the question. Okay? Then it's just a matter of neatening this up. So it expands to 4x plus 28 plus 6x minus 3, which when you collect together your like terms, you should end up with 10x plus 25 all over 12. Okay, the next one looks really scary, and it has been very deliberately made quite complicated. So at this point in time, hopefully you know that to divide by a fraction, we multiply by the reciprocal. Okay? That hasn't helped us a great deal, but we don't have to divide. Now what we need to do is start factorising. 3ab plus 5a plus 21b plus 35. So 4 terms, we don't have any common factors, so we are going to be grouping in pairs. So 3ab plus 5a has a common factor of a. And 21b plus 35 has got a common factor of 7. Okay, now looking at the bottom, b cubed minus 8, well that's a difference of 2 cubed. So when I want to factorise that, we remember that we're looking at the factors of b and 2, and so then we square the first, the product and then square the second. And then we have to figure out which signs go in, and they are the same, the opposite, and always positive. So that's how we factorise the b cubed minus 8. Hopefully we're getting more comfortable with that. So 3b squared minus 12b plus 12. Well, there's a common factor of b. Sorry, there's a common factor of 3. Leaving me with b squared minus 4b plus 4. And the bottom, now let's have a look. 9b squared plus 30b plus 25. Well, 9b squared is 3b all squared, and 25 is 5 squared, and 3 5s are 15, so 30b is twice the product, so we've got a perfect square here. Okay, so let's have a look. We need to keep neatening this up. So on the top on the left, we've got 3b plus 5 outside of a plus 7. We can't do much to the bottom. It's already been fully factorised. Now looking at the right, b squared minus 4b plus 4 is a perfect square. So we've got b minus 2 all squared, and that should be over, and we already factorised the bottom, so that's fine. So now we start looking, well, what can I factor out here? Well, I've got a 3b plus 5, so I can cancel out one of those. Now, when we're cancelling out with fractions, it's basically one on top, one on bottom, and it doesn't matter which part of the fraction they come from, because all of the numerators are going to end up together and all the denominators are going to end up together. So we can cancel out across the fraction as well. So I can also take out b minus 2, which will cancel out and leave me with just 1b minus 2. So what this is going to end up with is 3 outside of a plus 7, b minus 2, all over 3b plus 5, and then we've got b squared plus 2b plus 4. So it's not pretty, it's quite an ugly one, and there's a lot of steps involved, but every single one of those, common factor, grouping in pairs, cubics, perfect squares, you can do. So if you take it one step at a time, and the steps that you take don't have to be in the order that my steps were, but as long as you take each step and then cancel down properly, you should end up with the right answer. That's everything you need to know to be able to do exercise 216 and 217. Make sure you know this stuff inside and out, guys. So if it's something you struggle with, do a lot of practice. If you're pretty good with it, then make sure you hit the hard ones.